Today, we're going to be talking about percent of change. So sometimes you might be given an initial number, and then it might increase or decrease to another number, and be asked, what is that percent of change? So percent increase, what's the percent decrease? So last time we talked about using the proportion percent over 100 equals part over whole. And we use this proportion to solve for percent of numbers. Now we're asking the question, from one number to another number, what is that percent change? And so the only difference is in the right fraction of our proportion here. Instead of part of a whole, we're going to use difference over original. Now notice how there are three parts to this proportion. We have the percent, we have the difference, and we have the original. So the percent, what is that? Well, that is what we are trying to find. What is the percent of change? So we don't know that, and I'm going to use x to represent that amount. What is the difference? Well, the difference between 99 and 55, 99 and 55 is 49. So our difference is 49. And our original value is 50. From 50 to 99. Using what we know here, we're going to plug these values into our proportion here. So we have x over 100 equals our difference, which is 49, over 50. And we're going to create a new equation by cross multiplying here. 50 times x is 50x equals 100 times 49 is 4,900. And if we divide both sides by 50 to solve for x, we get x equals 98. So it can't be a 132 increase, it can't be a 132 increase. Well, from 50 to 99, is that an increase or a decrease? Well, it's an increase. So it's a 98% increase. Here's another problem. Again, we're going to use the same proportion that we used earlier. Percent over 100 equals difference over original. I'm going to go on the side here. What is my percent? Well, that's what we're trying to find. What is the percent of decrease? I don't know that amount, so I'm going to use x to represent that amount. Do we know the difference? Well, we know that the difference between 94 and 23.5 is 70.5. So our difference is 70.5. And our original amount is 94. From 94 to 23.5. Plugging in what we know here into our proportion, we're going to get x over 100 equals our difference, which is 70.5, over our original, 95. We're going to cross multiply to form a new equation. So 94 times x is 94x. 100 times 70.5 is 7,050. If you solve for x and divide 94 on both sides, you're going to get x is equal to 75. And what does the 75 mean in the context of our problem? It's a 75% decrease. Here's another problem. This time we're starting with 47.2 and we're going to 82.5. And we're being asked what is the percent increase. Again, we're going to start with our proportion here. Percent over 100 equals difference over original. And I'm going to make a note on the side here. What is our percent? Well, that's what we are trying to find. What is the percent of increase? And I'm going to use x to represent that amount. Do we know the difference? Well, if we do 82.5, we take away 47.2, we get 35.3. So our difference is 35.3. What is our original? Well, it looks like we started with 47.2. So that is our original. Using what we know here, we're going to plug in everything into our proportion here. So we have x over 100 equals our difference of 35.3 over our original 47.2. Cross multiplying here to make a new equation. X times 47.2, we get 47.2. X is equal to 100 times 35.3, we get 3,530. Solving for x here and dividing both sides by 47.2, we get x is equal to about 74.78. But the problem tells us to round our answer to the nearest tenth. So we look at the tenths place here, and we look to our right door neighbor. If that number is 5 or higher, we round up to 8. If it's 4 or lower, we keep the 7. Because the 8 next door is 5 or higher, we're going to round our 7 here to an 8. So our final answer is 74.8%. Percent increase.